In this session we will discuss slope-intercept form as our third graphing method. Alright. Alright, slope-intercept form as our third graphing method. Previous two we talked about was were three graphing methods, this being the third. The first one was the table of values, and the second being using the intercepts. Okay, so this is our third and last graphing method that we would use for graphing linear equations for our class, for this class. So again, slope-intercept form is y equals mx plus b, where m represents the slope and b represents the y-intercept. Okay, so slope-intercept, because your key ingredients for this equation are the slope and the y-intercept. So slope-intercept equation, slope-intercept form, you need a slope and you need a y-intercept. Alright, now steps. As far as the steps we want to use to graph with this method are as follows. Alright, first step, you want to get the equation into slope-intercept form. Alright, you want to get the equation into slope-intercept form. So that's the first thing you want to do. So solve for y, making sure your x term is before your constant on the other side of the equal sign. Alright, now next you want to plot your first point. Plot your first point on the y-axis at B. At B. Alright, so whatever number that holds this place, once you put the equation into the proper form, whatever value that's right here, you go to that value on the y-axis and you make your first point. Okay, then after that you use your slope, which is rise over run. So you use your m. Alright, you use your m once the equation is in proper form to count rise over run. Okay, and you're counting from B. From B, use m to count your rise over run from B to get your second point. Alright, use m to count rise over run from B to get your second point. Okay, you're not counting rise over run from the origin, you're counting it from your first point, which is your B. Alright, and then once you've done that, connect the 2 points. Alright, so let's look at some examples real quick. Here, first example, let's say we have y equals 3/5 x minus 2. Okay, well, let's go ahead and make our graph, since we will be graphing. Establish us a nice size graph here, if at all possible. Okay, and there we go. So we have our y-axis, we have our x-axis. So if we were graphing this first equation, it's in the form. Okay, so we've done the first thing, it's in the form. Y equals mx plus b, y equals mx, and there's my b. So now the second thing says plot my first point on y-axis at b. Well, my b happens to be at -2. So I go to the y-axis, and I count down -1, -2. So I make a point at -2. There it is. Okay, so now I've done the second step. Now I'm going to use my m, and my m in this case is 3/5. Okay, positive 3/5. So because my 3 is positive, I'm going to count up, and because my 5 is positive, I'm going to count right. Alright, so use my m to count rise over run from B, from here, to get my second point. So I'm going to count up 3. So from here I'm going to count up 1, 2, 3. Then I'm going to count to the right 5. So right 1, 2, 3, 4, 5, and that gives me my second point. Alright, so from here I went up 1, up 2, up 3, then I went right 1, 2, 3, 4, 5, and now connect these 2 points. Alright, and that would be the graph of the line. Okay, that would be the graph for this equation, and that's all there is to it. Alright, and notice here our slope is positive. Our slope is greater than 0, and we said anytime you're graphing the line of an equation with a slope greater than 0, we said in our slope profiles that that graph better be going up to the right. And if you notice, this graph is going up to the right when you read from left to right. Okay, we talked about this in the session on slopes. So with a positive slope, we're looking at a graph that's going up to the right. Okay, so now let's look at another example. Okay, let's say we have for x plus y equals 1. Alright, we want to graph this equation. So first step, we want to get the equation into the proper form. So to get it in the form, I have to get the y by itself, so I subtract 4x from both sides. So now I have y equals a -4x plus 1. So now it's in the form. So good. Plot my first point on the y-axis at B. So my B is a +1 now. So I go to the y-axis to +1. There it is. Make my first point. Now I'm going to use my slope to count my rise over run from B to get the second point. So my slope is -4, and -4 is like saying a -4 over 1. You can write any whole number by writing that number over 1. So now because my 4 is negative, I'm going to count down 4, and my 1 is positive, so I'm going to count right 1. So down 4, right 1 from my B. So if I'm going down 4 from my B, I go down 1, down 2, down 3, down 4, then I go right 1. Puts me right here. Alright, and so if I was connecting the lines, that's real ugly. Let me not do that. Here, I'll try the actual line. Yeah, that's better. Okay. And again, it's important to make sure we put our arrowheads on the ends to show that the line is continuous. Okay. So if I was graphing this equation, this would be the graph. Notice now, my slope is negative now because it was a -4. Alright, so it's a negative slope. And we said when our slope is negative, in other words, when our slope is less than 0, then when we graph the equation of a line that has a slope of less than 0, it will go down to the right. And if you're looking at this equation, at this slope, at this graph, from left to right, it's going down to the right. Down to the right, like we said it would, based on our profiles of slope. And again, we talked about this in a previous session on slopes. Okay, So that would be how you'd graph that. Alright, third, let's do one more example. Let's say we have x minus 4y equals 4. First step, put it in the form. So minus 3x minus 3x. So now I have a negative 4y equals a negative 3x plus 4. Alright, now I need to get the y by itself by dividing everything by negative 4. 5 by negative 4, 5 by negative 4, so I have y equals. Now, here's the biggie. Negative 3 over negative 4. Alright, a negative over negative, remember, is a positive. So this gets rewritten as 3 over 4x. Gets rewritten as 3 over 4x because a negative over negative is a positive. And then a positive 4 divided by a negative, positive divided by a negative is a negative. So that gives me minus 1. So now my equation is in the proper form. So I can go to the second step, plot my first point on the y-axis at B, which would be a negative 1. So negative 1 on the y would be right there. There's my first point. Now I have 3/4. It's positive, so it'll go up 3. The 4 is positive, so it'll go right 4. So from my first point, I would go up 1, up 2, up 3. Excuse me, didn't mean to make a dot there. So from my first point, up 1, up 2, up 3. Then to the right 4. So over 1, right 2, right 3, right 4. Make my second dot there. Clear this up right quick. Make my line. There you have it. Alright, so this would be y equals 3 over 4x minus 1. Okay, and notice again, slope is positive, is going up to the right. This one would be y equals negative 4x plus 1. Alright, and remember, notice slope is negative for this one, so it's going down to the right. Slope is positive for this one, up to the right. So negative slope down to the right, positive slope up to the right. Alright, so this illustrates our third and final graphing method, which is slope-intercept form, and it shows you how an equation represents some graph. How an equation represents some graph. Okay, so this will conclude our sessions on graphing for test D. As always, if there are any questions, please feel free to contact me either in class or in my office during office hours. And at this time, we will conclude the session.